Okay guys, welcome to Doozer Shop. The topic of this video is going to be tooling for predominantly horizontal boring mills. I've got the Giddings and Lewis here, and these older machines use Morse taper tooling in the boring bar, in the spindle, whatever you want to call it. Of course, newer machines use 40 taper, 50 taper, NMTB tooling like a modern CNC mill might, with a drawbar or a, probably not a pull stud, but a power drawbar. But anyways, I've got a Giddings and Lewis 25T, and a couple of you guys out there have these. And mine's 4 Morse taper. I know 5 is more popular. But let me show you how the Morse taper is retained. Now let me back up a bit. If you're just drilling, right? If you're just drilling with a chuck, okay? There's a Jacobs chuck, and you have a Morse taper arbor, with the tang for knockout. And drilling, you're pushing straight in, okay? Now milling is different, of course, as you know. There's side forces involved, right? So let's say I got a milling, I guess I call this a milling chuck. It's a ER40 extended range Rego Fix collet adapter. So the collets go in there, and there's the Morse taper. And normally you would have a drawbar, right? So that's 5/8 11 thread. But the spindle on a horizontal boring mill is solid. At least the old ones are solid. So this won't work. So, let me get you another one here. I'll put the cone on, or the closer cap, so it looks like, the same as the other one I just had. So again, now we got at least a tang, right? We've got a tang on the end, which helps for rotation, but it doesn't help to retain it if you're putting side forces on it with a mill cutter, with an end mill or whatever. So what this one has is a slot. Okay, that's a slot. So what it does is you put a wedge in the spindle. Let me hold it. It's a key. It's a little bit of a taper. It's not much taper to this. There's only 10,000ths taper from one side to the other. But what it does is the spindle on the mill, the boring mill, is also slotted. And you hammer this in and retain it. That's how it is, okay? So, like I say, that's what it ends up looking like. So, these are purchased adapters. Like, I bought this ER40 to Morse taper 4 adapter, and I milled that retention key slot in there, okay? And you might see there's some Dykem bluing, and there's like a little punch mark, a little drill point, okay? That is the gauge line. Okay? And what you got to do is, let's take you over to, I should have been better prepared for this. All right. On my windowsill, I've got a couple. Do I have 3 of these? Oh wow, I thought I only had 2. Apparently I bought 3. But anyhow, these are taper gauges. Here's a 5 and a 4. And Pratt & Whitney 4 Morse taper. Okay, so these are the male taper gauges. Now, I'm trying to buy more. I've got one, I can cover it up. And four Morse. Okay, is this a Pratt & Whitney too? No. Yeah. Brown Sharp. Brown Sharp. So what you do is, let's get one of these as an example. Is you take that and you make sure everything's clean as a whistle, right? Okay. So now your arbor is in the gauge, and what you do is you ink that up before you put it in the gauge, and you scribe a line with a little scriber, and you mark the gauge line all around that, okay? And then once you have the gauge line established, you know, I think I put a little, I'm trying to set that down where it's not set on my file. Once you mark your arbor, your shank, whatever Morse taper 4, shank, tool holder, whatever, then you have a place to measure from. Okay, so this is Doozer's cabinet, and it's steel and magnetic, so I hang stuff here. So this is the dimensions to put in that key slot. See, it says shanks for Giddings & Lewis boring machine spindles. This document, this picture, exists in 2 places that I've seen. In the Giddings & Lewis literature, it exists, and also I got this out of the Scully Jones book of tooling. Scully Jones made a lot of adapters back in the day for everything. So let me kind of zoom in there. Okay, so your gauge line, this number is not always the same and reliable, so that center line, construction line, whatever, your 1 3/8 from the edge of that slot, and the slot is 15/16 by 13/32, just a little over 3/8. So I use a 3/8 end mill. I marked this all out, and you know, you gotta have a little cheat sheet. So from the gauge line where I scribe it and make the dot to the center, you know, you use a wiggler or a sharp point in the mill, and you get your 0 coordinates. 0 your readout or your dials. I pity you if you have to use dials. Buy a readout. And it's 1.844 to the center. Then work your 3/8 end mill back and forth, and then do a, you know, back and forth as you go deeper and deeper and deeper and deeper. And when you finally plunged through do a full pass perimeter 15 thousandths offset to get that, what was that, 30 seconds. So that's how you have to mill these. These shanks that I had were only about 40C, between 30 and 40C Rockwell. So I use a carbide 3/8 end mill. You could probably use a high-speed steel end mill, but I've grown to hate those, seeing as carbide is getting so cheap and it's so rigid. That's how and I'll show you a couple more, but that's how I get that cross tang. The old, instead of having a tapered key, some other people that had better ideas maybe made a little wedge retainer. You know, I don't have a picture, but Davis made a more scientific version of that, but that's stupid simple and that works. I think Tom from Hilltop Machine Works has a good video about making one of these. So check out Tom at Hilltop Machine Works. But I don't know, I was gonna make one of these a number of times and it just felt kind of clunky to me. And then I saw a video of all places, Keith Rucker's vintagemachinery.org site there. He had a quick change piece of tooling for his, I forget, he's got a Lucas with a 5 Morse taper. And I don't remember if he had some kind of quick change. I think it was an Ericsson quick change. PDQ quick changes, I think, might have used something similar, and PDQ is Portage boring mills, and Portage made the PDQ triangle type quick change. But anyways, yeah, I kind of got inspired from all that, and so I want to show you, I got a couple milled, right? This is an ER40 adapter. That's another ER40 adapter with the drawbar end, and I wanted to use the one with the knockout tang. And let's see, my drill chuck. I got a threaded, you know, for the boring head, which threads in there, and you know, this 1-inch end mill holder. Cool. So let's pretend that I want to put the boring head in. All right, this is a 4-inch Criterion, I think, and they have threads inside. So basically the boring head screws on to an adapter shank, right? So I'm going to use this to my advantage. I'm going to take it out and put the boring head down. So what I've come up with, I didn't come up with this. I kind of seen pieces and parts, and instead of, you know, the solid key, which is tapered, I made a key which has a 1/4-inch thread in the middle. And I drilled a 1/4-inch hole maybe you can see that. It comes out there. So what you can do, that's it's just a 1/4-inch Allen head screw. I'll just gotta move away. And once you put the screw in there, you can see now that it goes in that cross hole. So if I were to stick this key that I made in there, and I thread, I'm sorry, I got the camera on this, oops. Sorry. All right. See? There's the screw, and when you tighten this, obviously it draws up. It pulls on the tang, right? Okay, that's snug. So you can see now that tang is fully forward. So let's put it in the spindle. You can see the undercuts in there, so it actually gives it pressure to the spindle. So let's take this out and let me show you for real. I know this is a long... Okay. So if I want to mount this in the spindle, I take the boring head adapter, in this case, right? And I put that in there lightly. Then I take my key. It's just terrible camera work. Right? I'm going to take that. I'm going to put the notch out towards the front there. And I'm going to take my handy dandy Allen screw. And I'm going to tighten it. I'm going to feel it engage the thread. See that move? I'm going to tighten that. And that's going to hold it in. And, you know, don't go crazy. Just give it a little bit. Okay, so now the screw is in there. Allen screw, it's 1/4 20. I made this flush and countersunk it, counterbored it. And that's all that there is. Instead of your solid key, right? You know, with no hole. And I could have used this one, but this, I wanted to keep it in case I needed to have stuff with the taper. I wanted to show you, that's right, I forgot. I wanted to show you the old, what it would look like with the old key. So, I'm getting ahead of myself. So, instead of that key, let's just put in the Davis key. It says large and small, so you put the small end in. Is it that? I don't, so this thing, it's, both sides are tapered, so you got to find out which. Is it that one? No, maybe it was this side. That one. Okay, no, that's right. So let me put that up. So you see how much that's protruding out? It's maybe 1/4, 3/8 of an inch. You would hammer that in, right? You would tap that in, and it would draw that in. And yeah, it's okay. It's okay. But like I said, all these dimensions have to be perfect for it to work. And like I said, from one side to the other, this is tapered only 10 thou. You know, from here to there, it's only 10 thou. So, and I milled these slots in the arbors. You know, I milled these things exactly with the gauge line. Does this have a gauge line mark? Yeah, I think it does. Yeah, this one does too. I don't know if that's what I showed you before. But that's how I mill them, right? So anyways, let's use the new system. This is the key that I made. Stick it in. Put your screw in there. And you know, an Allen head screw is like better than grade 8. So these are strong guys. So you got your boring adapter, and I think this is 1 inch 18 or something threads per inch. No, it's 1.25 inch 18. I don't know. I forget what it is, but they're standard criterion. There, now you can bore, right? You can bore to your heart's content. And nothing will fall out. This thing comes out 26 inches. This is so impressive to me how much this comes out. But anyways, so just to illustrate, I'm doing this a little bit for me, and I'm kind of having fun here because I'm really proud that I got this accomplished and these pieces made on the Bridgeport. So now, oh, and by the way, this is the R8 shank for the Bridgeport with the same, thread on it. And I milled some flats so you could take it off with a wrench. But yeah, this is the R8 with the same boring bar or boring head thread. Okay, so to get this off, like I said, I didn't tighten this super tight. I experimented a bit how tight to make it and would it still release. So that comes out, and then you take your knocker. This is your taper knocker, and that goes in the back. And I don't have a hammer, so I'm just going to use a little piece of steel, right? And it just comes right off, and da-da-da-da. So I got the boring head, I got the end mill adapter for a 1-inch end mill. Putnam has the 2 set screws. And Weldon is 1 set screw, for those that like the trivia. And again, this is the ER 40 adapter. And what's great about this is you stick it in the center because it holds a collet anyways. No, I forgot to stick this in first. You put that in there, it goes in nice and easy. Get your Allen screw. All right, and then, excuse my reach, these are the ER collets, and they're set up to do 1-inch capacity. So then you stick your end mill in there, your collet in there, and you bada bing. Now you can hold your up to 1-inch end mills, and I got the whole set. So that's going to be super handy, right? So now I can hold end mills. I got a drill chuck, I always had that. I can hold boring heads. I can hold end mills. And I got the Putnam adapter. Actually, yeah, here's a smaller boring head adapter. This is 7/8 some kind of thread to Morse taper 3 with a drawbar, and that's what the different boring head with the smaller shank, but that's what the SIP take. All right, so as I said, I got an adapter for a boring head. I got a couple of those in the ER collets, and then the drill chuck, and I got the 1-inch end mill adapter, which really I could put end mills in this that are up to 1 inch too. So I just wanted to share that with you guys and show you how nice and easy it works. With my situation right there, right? That's the dude. That's all it is. And I rounded the ends because that's how the slot is, with a 3/16 radius, and this is 3/8 wide, so it's a full. And then I just cut that deeper so, you know, if the shank, if there's any recess that needs to be overcome, you know, so it actually puts pressure on the spindle. But that's it, man. I'm pretty happy about how all this works. And like I say, I had to put the 5 Morse taper adapter in the lathe. And is this the right one? No, I got different length. Is this the right one? Yeah. See how the screw, right, when you push it in, it goes all the way, and not quite touching the top. There's some, but I went for full thread engagement. But that's what it is. Sorry, that's what it is. In my opinion, that's way better than a wedge lock. And you have to unthread your boring head, but so what? You know, I mean, it's like threading off a thread on lathe chuck. It's so easy to do, and they don't get tight if you don't, unless you're boring in reverse, right? I mean, just don't bore in reverse. I mean, you could. I mean, you could put a crescent wrench on this, right? A big honking crescent wrench, like an 18-inch crescent wrench. And that's how, if it gets tight, you just take it off. But anyhow. But that's kind of it. I know it's a lot of talking, but I think this is really important to understand, you know, what that slot is about. And, you know, the old school way, like I said, is to use the solid wedge that's tapered. And that, there, maybe it's this way. Yeah. Right. Yeah, see, this one doesn't stick out as much. So that would suck that in. Like I said, they're so inconsistent, even if you get the tolerances perfect, you know, how it's supposed to be. But I am just thrilled as punch that I'm able to have something and positively retain the tools in the old, let me back up, the Giddings and Lewis horizontal boring mill. Anyways, well, I hope you guys appreciate this. Maybe it helps somebody. It's a revelation to me. I mean, it's just something I struggled with, and I that's not bad. That solution's not bad, but you know, putting a drill in the shanks and, well, let's go over in the lathe. I'll show you. Two lathes have 5 Morse taper. The Hendy tool and gauge maker does. And I don't have the tailstock finished yet because the quill is still in the Colchester. And so the Hendy tool and gauge, I took the chuck off of it. It's a D16 chuck. This chuck is pretty darn spanked. It's sprung, it's missing some jaws, but it's a set true, but the jaws are sprung. And I finally found my 5-to-4 Morse taper sleeve. That's what that is. So I just drilled that hole. I had some longer drill bits that I was able to use. And that worked. So I know you guys like to see different stuff in the shop, and I did the slots over on the Bridgeport, you know. the standard, every shop needs one Bridgeport, and then, you know, I got the readout on it, and just did it in a vise. You put the holders, you open the vise up, and you squeeze the shanks the long way. You know, because they're tapered, you can't squeeze them like this. You can't mount it like this. So just, you know, if this was your taper adapter, you know, squeeze it like that. Open the vise all the way, and then mill with your y-axis back and forth. You know, so that's how I did it. And I could use the Gorton, but it's my, you know, where I put the tools when I'm working on this mill. But it's pretty fun. I do enjoy rambling a little in my videos. People probably hate it. Actually, I've got adapters, you know, the HLVH is 5C, and the Sagami lathe over there is also 5C. I've got adapters from 5C collets to Morse taper 4. So I could have technically done it, you know, in the Sagami, but I just thought the spindle alignment and everything was better on, yeah, Pratt & Whitney. So, anyhow, been talking too much. You know, some people like that, some people don't. They just fast forward through my sorry excuse for videos. All right, I'm gonna go try to edit this, upload this, and I hope you enjoy, you know, my little contribution to the tooling on Morse taper tooling for boring mills. So thanks for watching. Until next time, this is Doozer Shop.